5 foods are sitting on your plate right now because someone told you they actively lower blood sugar. A doctor tested all 5 of them using a continuous glucose monitor. Every single one spiked glucose in the very patients who trusted them most. Today, we name all 5, what they do to your insulin, why the label lied, and exactly what to eat instead. Food. Number 5. Agave nectar. This is the one that doctors and nutritionists pushed hardest for diabetic patients. The pitch was simple, and it sounded scientific. Agave has a glycemic index of just 15 to 19. Table sugar sits at 65. Honey sits at 58. Agave looked like the clear winner for blood sugar management, a natural sweetener that barely moves the glucometer. And that part is technically true. Agave does not spike blood glucose immediately. That is precisely why it is so dangerous. Here is the mechanism the marketing left out. Agave nectar is approximately 85% fructose, a significantly higher fructose concentration than high fructose corn syrup, which sits at 55%. Unlike glucose, which every cell in your body can metabolize, fructose can only be processed by your liver. When you consume agave, your glucometer stays calm. Your doctor sees a normal reading, but your liver is being flooded with a concentrated fructose load that it must convert, first into glycogen, and when that is full, into fat through a process called de novo lipogenesis. Over time, this drives fatty liver, raises triglycerides, reduces insulin receptor sensitivity in liver cells, and produces a form of insulin resistance that builds invisibly, never appearing on a standard blood sugar test until it is severe. A study in mice comparing agave to table sugar over 34 days found that while blood glucose appeared lower in the agave group, metabolic markers of liver stress and insulin resistance were measurably worse. The glucometer told one story, the liver told another. And if agave surprises you, food number 4 will, because it is something most people eat every single morning, believing it is actively protecting them. Food. Number 4. Flavored low-fat yogurt. Low-fat yogurt became a cornerstone of diabetes-friendly eating based on legitimate research. Plain, full-fat Greek yogurt genuinely has a glycemic index of around 14, one of the lowest of any food. It is high in protein, high in fat, and rich in probiotics that improve insulin sensitivity over time. Everything about plain Greek yogurt supports metabolic health. The problem is that almost nobody eats plain yogurt. They eat flavored yogurt. And flavored low-fat yogurt is a categorically different product. When manufacturers remove fat, the ingredient that slows digestion and blunts glucose absorption, they replace it with sugar to restore palatability. A single serving of fruit on the bottom or flavored low-fat yogurt commonly contains 15 to 25 grams of added sugar. Its glycemic index jumps from 14 to between 33 and 40. Some varieties contain more sugar per serving than a glazed donut. The low-fat label activates what psychologists call the health halo effect, a cognitive bias where one positive attribute causes people to overlook everything else. Research from Cornell University found that people eating foods labeled low-fat consumed up to 50% more of them than those eating the same food without that label. In metabolic terms, the patients who switched from regular yogurt to low-fat flavored yogurt in the name of blood sugar management were producing measurably larger post-meal glucose spikes than before. Plain, full-fat Greek yogurt, no fruit added, no flavoring. That is the only version that delivers what the category promises. But the pattern of trusting the label gets worse with food number 3 because this one is sold directly on store shelves as diabetic bread. Food number 3. Multigrain and brown bread. The shift from white bread to multigrain bread is one of the most universally recommended dietary changes for people managing blood sugar. It is on the packaging, it is in the medical guidance, it is what every nutritionist tells their clients. And there is a version of multigrain bread where that advice is entirely correct. Bread where whole grains are listed first, Fiber content exceeds 4 grams per slice, and every grain in the product is genuinely intact and unrefined. That bread exists, but it is not what most people are buying. The overwhelming majority of commercial multigrain bread sold in supermarkets uses refined white flour as its primary ingredient, and then adds small quantities of oats, seeds, or other grains to justify the multigrain label. The glycemic index of this version sits at 66. White bread sits at 70. The difference is 4 points on a 100-point scale. In practice, using a continuous glucose monitor, most patients cannot distinguish between the two products on their blood glucose trace. A meta-analysis of 7 randomized controlled trials found that substituting brown rice, the grain equivalent of this bread swap, for white rice produced no statistically significant improvement in HbA1c or fasting blood glucose in patients with prediabetes or type 2 diabetes. The whole grain substitution that patients were told would transform their metabolic health delivered in clinical trials almost no measurable benefit at real-world portion sizes. The fix is simple, but requires reading the ingredient list, not the front of the package. If the first ingredient is not whole grain flour, regardless of what the label says, the product is white bread in disguise. And what food number 2 does to blood sugar is arguably even harder to accept because this one has been prescribed as medicine. Food number 2, commercial green smoothies. Green smoothies became the defining symbol of metabolic health. Spinach, kale, spirulina, cucumber. The green color alone signals virtue. Wellness culture built an entire identity around them. And a smoothie made from whole blended vegetables with water or unsweetened nut milk containing minimal fruit is genuinely a reasonable metabolic choice. Fiber is retained. Glucose absorption is slowed. The cellular matrix of the vegetables, though damaged by blending, still provides structure that moderates digestion. But the smoothie most people drink, from a juice bar, from a supermarket refrigerator shelf, from a meal replacement brand, is not that product. Commercial green smoothies use apple juice, mango juice, or pineapple juice as their liquid base. They contain 3 to 4 portions of high-sugar fruit to make the vegetables palatable. They are commonly sweetened with agave, honey, or dates. A single 450 milliliter commercial green smoothie frequently contains 45 to 60 grams of sugar, the equivalent of 2.5 cans of cola, delivered in liquid form, with the fiber matrix of the fruit largely destroyed by high-speed blending. Liquid sugars, stripped of fiber and consumed rapidly, produce dramatically faster and higher glucose peaks than the same sugars in solid food. The gut has no physical barrier to slow absorption. The pancreas receives a concentrated glucose signal in minutes rather than hours. A 2020 study published in Nutrients found that fruit smoothies with juice bases produced significantly higher post-meal glucose peaks than the equivalent whole fruit consumed intact, despite containing identical sugar content. The product is green. The metabolic response is not. If commercial smoothies are a surprise, food number 1 will be the hardest one yet, because it is the direct swap that millions of people made specifically to fix their blood sugar. Food. Number 1. Brown rice. This is the one that will cause the most disagreement. Brown rice is not a fringe health claim. It is in the official dietary guidance from diabetes associations in multiple countries. It is what doctors have recommended for decades as the direct, evidence-based replacement for white rice. And unlike the other foods on this list, there is genuine science supporting the switch. In theory, brown rice has a glycemic index of approximately 68. White rice sits at 73. On paper, brown rice is lower. It retains the bran layer, which adds fiber and slows glucose absorption. In controlled laboratory conditions, eating brown rice in a standardized portion produces a modestly smaller glucose spike than the same portion of white rice. The recommendation made sense based on that data. Here is what the clinical trials found when they tested it in real patients. A meta-analysis of 7 randomized controlled trials involving 417 adults with prediabetes or type 2 diabetes measured the effect of replacing white rice with brown rice on HbA1c and fasting blood glucose. The result? No statistically significant difference. Neither HbA1c nor fasting glucose improved meaningfully with the switch. The glycemic index gap of 5 points, 68 versus 73, is simply too small to produce a measurable clinical outcome, particularly when portion sizes in real life are larger than the standardized amounts used in GI testing. A cup of brown rice still delivers approximately 45 grams of available carbohydrate. The bran layer slows the spike by minutes, not meaningfully enough to change the metabolic outcome at that carbohydrate load. This does not mean brown rice is worse than white rice. It means the swap alone, made in isolation at real-world portion sizes without changing the quantity of rice consumed, does not deliver the blood sugar benefit patients are told it will. The intervention that actually works is not the type of rice. It is the portion size, the food eaten alongside it, and the total carbohydrate load of the meal. A small portion of white rice eaten after vegetables and protein will produce a better glucose response than a large portion of brown rice eaten alone. The mechanism, food order, fiber buffer, insulin demand, determines the outcome. The color of the rice does not. Every one of these 5 has a direct swap. Change one this week and watch what happens to your numbers. If this changed the way you read a food label, hit subscribe. More coming soon. Subscribe, like, comment. Which food shocked you most?